Welcome to clickmyproject.com. Now we are going to discuss about the project learning non-Euclidean representation with SPD manifold for myoelectric pattern recognition. Now we are going to discuss about the abstract of the process. The electromyography is the measure of electrical activity produced by the muscles, which is usually represented as a function of time. The EMG can be used in various applications, including the identifying the neuromuscular diseases, controlling signals for prosthetic devices, then controlling the machines, robots, and several kinds of machines. EMG-based hand gesture can be helped to develop the good computer and man interfaces that increases the quality of the life of the disabled or aged peoples. So the myoelectric signals generates from the movement of the muscles as well as the vein of lower portion of the forearm as well as from the upper portion of the wrist connected to the forearm. From the received forearm electric myography signals separations of individual signals through the segmentation, and then the corresponding evaluated values are used as an input for the classification of hand gestures. Hence, in this process, we used the EMG based hand gesture recognition, and then the gesture will be recognized and displayed. Finally, the performance of the process will be evaluated by means of the accuracy. In case if the accuracy is high, means the performance of the classification is high. Now we are going to discuss about the flow diagram of the process. This is the overall working flow present in this project. The module consists of input signal, pre-processing, feature extraction, feature matching, that is nothing but the classification. Finally, the performance estimations. These are the modules we have done in this project. And first, the input signal is taken from the dataset. The dataset consists the EMG signals of the various activities. After getting any one signal as an input from the dataset, we just move to the second stage of the project, that is the pre-processing. In this pre-processing, we have two kinds of pre-processing methods is there. One is filtering, then the another one is normalization. So the filtering is used to remove the noises present in the signal. If any noisy peak is present in that signal, means that particular peak ranges will be eliminated. Then in case if the normalization is needed, means we can apply the normalization method. After applying this two method, we just move to the third stage of the project, that is the feature extraction. So in this feature extraction, we have to extract the features from the signal by means of the three kinds of method, that is the TD, DWT and MNF method. By using this three method, we can extract the features from the signal. Then the corresponding features are combined together to generate the test feature. After generating the test feature, during the classification step, we have to incorporate another kinds of data, that is the train feature and labels. So the train features consist the features of the whole dataset signal. Then the test feature consists the features of the input signal. The label is the consist of by means of whether which kind of activities that represents the label. After importing these three into one feature matching method, we have to apply the SVM classification to classify whether which kind of activity is there. After that, finally, performance estimation. So the performance is estimated by means of the accuracy, sensitivity and specificity. By using these three parameters, we can justify our process is efficient or not. Now we discuss about the running procedure of the process. At first, open the MATLAB 2015B and change the current directory. If you want to execute the process, just right click in the main_GUI.m and select the option run. Once you click the button option run, the user interface will be open. In that user interface, you can see the several push buttons in the right side for the controlling actions, then the several axes and table in the left side for the display purpose. First of all, click the button input signal. Once you click the button input signal, the dataset will be open. The dataset will be in the form of CSV. The CSV files consist the lot of signal values. So we have to select that signal and then click open. After clicking the button open, we have imported the signal from the dataset. The particular signal is plotted in the axis 1 with the title of import EMG signal. After importing the signal from the dataset, we just move to the second stage of the project, that is the pre-processing. So in this pre-processing, the pre-processed EMG is shown in the axis 2 with the title of pre-processed EMG. So here we have two kinds of pre-processing is there. One is the signal is limited, then the signal is noise removed. After applying these two techniques, we just move to the third stage of the project, that is the feature extraction. So after clicking the button feature extraction, already we have discussed in the flow diagram, we have three kinds of feature extraction in this process. So the values are graphs are represented here. The corresponding values are represented in the feature 1, feature 2 table as well as the feature 3 table. So totally we have getting the three features. The first table represents the features of first features, then the table 2 represents the features of second, then the table 3 represents the features of third. Then we just move to the classification. So in this classification step, once you applied the classification, we have to enter the predictions value. So we have to enter any predictions value. So the predicted value is wrist fluctuation. The corresponding result is shown here. After doing the classification, we just move to the performance estimation. This performance estimation, we have three kinds of performance, that is the accuracy, sensitivity and specificity. Corresponding values are displayed in this as well as in the graph format. Thanks for watching this video.